Super. So hello everybody. My name is Roland. I'm an architect from Germany, and I'm in the committee of the jury for the student contest of Isover. And you are joining, as far as I know, and it's an interesting place you are designing the project for in Brest, Belarus. I have been there, and maybe later you'll have some questions about the site. I can give you some answers. But before that, we will start going through a short presentation about the principles of Passivhaus. And this will be the first presentation. The second will be about a house I have done by myself. Actually, I'm sitting in this house right now. It's a renovation to Passivhaus Standard. But first of all, why are we looking for Passivhaus quality? Because, easy to say, because we are responsible for the CO2 emission and the consequences if we don't cut the CO2 emissions, global warming, greenhouse effect, and so on. You know all about that. Tornadoes, hurricanes, extreme summer and winter conditions, everything's screwed up. So what we have to do is to really change the way we design buildings. And this means energy efficiency is most important, and the best energy efficient you get when you go for Passivhaus Standard. It doesn't matter if you are building big or small houses, doesn't matter where these houses will be, doesn't matter which usage these houses will have. Passivhaus quality will be and still is and will be in the future the best energy efficient way to build. So a postulation of the climate scientists tell us that the maximum CO2 emission per person a year should be 3 tons. So 3 tons, not very much. If you look at this chart here, and you see, for example, the red mark on the left or in the middle, it's Germany, Deutschland, where I'm sitting, where I'm living. I am German. We have 10, actually a little bit more by now, between 10 and 11 tons per person CO2 emission, which is horrible compared to the goal we know since years and years, and we're talking about the 3 tons. This is the red line, the 3 tons. And you see most of the countries, of the developed countries, have a lot more. So the big question is how to get down the CO2 emission to the level of 3 tons. And of course, it's not done by eating more healthy food and by using your bike a little bit more than your car, but you can only do it by cutting down the CO2 emission in our building systems. So we have built a house in Turkey. That's why you find some slides responsible for the Turkish situation, but it's the same everywhere. It's the same in your country, the same in my country, the same in all countries around the world. We have to decrease CO2 emission, but what we see is a constant increase. And it's unbelievable because everybody knows since a long time that we have to decrease CO2 emission. And how can it be, if all the laws are changing, if all the legal standards are changing, and everybody is trying to get down the CO2 emission, that it's still increasing? But that's the way it is. So what happens is we don't want to have a little of decrease to just bend the increasing range. We really have to go dramatically down, otherwise it's going to be increasing constantly more and more. Because a lot of the CO2 emission is depending on the development of the of the countries. As more as a country is developed, as more CO2 emission there is. And we have development everywhere on the planet, and we want it to be developed. So the most developed countries have the biggest step to do to cut down their emissions. And right now, in the whole of Europe, we have about a third coming out of the industry, a third about coming out of the transport, and the more bigger third coming out of the buildings. It's 40% more or less. So 40% is a huge, huge amount. That means we as an architect, you as a future architect, we have the big pleasure on the one hand side and the big question to answer, how to really cut down the CO2 emission. And I want it to be down by 10 or less than 10, maybe 5% in another 10 or 20 years. Everybody wants that, but the question is, how can we do it? And the principle must be cut down the CO2 emission, cut down the energy consumption, limiting of the demand of energy, the green basic, you see. And then the rest is smaller, even more smaller, getting rest as more energy efficiency we have, produce it by renewables, not producing it by burning coal or oil or gas. No, go for renewables for the rest and you're fine. And if there is a little tip on the top, then you might use a little fuels, but that's not the point we are talking about. The major point is the basic, the green one. You want to cut down the CO2 emission and the energy consumption. And if we are talking about energy consumption, we are talking about Passivhaus Standard. According to the standards you find everywhere in Europe and around the world, Passivhaus Standard is low, 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 very low down in the bottom. In our country, it's about 75% lower than the legal standard. So this is a huge step. But you can do it. There's hundreds and thousands of houses built already, and they all work perfect, and everybody's happy. And the cost is very small to do it. You just have to get the knowledge how to do it, and you have to focus your design on Passivhaus Standard. The way to this Passivhaus Standard, or here called eco design in buildings, quite easy. It's the walls, the cellar, the floor, whatever, the whole envelope of the house, insulation. And the same is with the airtightness. Wherever you run the insulation, you want to have the house airtight. So the whole envelope of the house has to be airtight as much as possible. And then you focus on the glazing. You don't want a single layer glazing, you don't want a double layer glazing, you want to have triple layer glazing, or let's say high performance, high perfected glazing. You don't want to have these old windows where it's leakage and where there's condensation and where there is no energy efficiency. You want to have high performance glazing. And because once you have a really solid and airtight and no thermal bridge building house envelope, then you need and you want an NVHR system, a mechanical ventilation and heat recovery system. That's no air conditioning, no air conditioning. It's just air inside, filtered air to get a perfect indoor air quality. Once these 4 steps are done, most of it is done, you need to have for Passivhaus Standard. Then you have to look at the lighting, you have to look at the heating system, you look at the rest of the energy appliances of their efficiency, and of course, to cover these needs, you need to have a focus on renewable sources, and that is it. It's not that difficult to do. And the secret, I call it the secret of a passive house. It doesn't have to be certified, but passive house can be certified, and that's another extra plus we have. The secret of the passive house is energy efficiency first, comfortable, affordable, and ecological. This is automatically done by a passive house. It's not 4 points you have to fulfill. Once you have built a passive house, you fulfill these 4 points in that order, and this is perfect. So what a owner gets, what your customer, former customer will get, is not a standard house where it needs to invest a lot of bills and pay bills in the energy consumption of the house. No, a passive house owner, you can really lean back and say, I have hardly any running costs. I have hardly any bills to pay. This is a second pension I get. For example, I'm sitting in a house here with 350 square meters, which is quite big, and my running cost of this house per year is 500 euros. 500 euros only to run the house. No more energy efficiency costs than 500 euros per year, compared to if it was a standard house to legal standards, I would have 10 times this bill at least. So you see what I earn out of the decision that I have redone this house to a Passivhaus Standard. So super. You find passive houses in all kind of sizes, all kind of usages, all kind of places everywhere around the globe. Meanwhile, of course, most of them are in Europe and most of them are in Germany. Second most is in Austria, I guess, because there's special, you get special money for it. But yeah, don't be scared. You can do Passivhaus Standard for all kind of needs. And of course, in your Isover student contest in Brest, you go for the Passivhaus Standard and you calculate it with the PHPP. So how does it work? The criteria. You see the the yellow line. The yellow line here, the insulation, running really around the house, everywhere. No thermal bridging, all around the house. Floor slab, walls, roof, no thermal bridge, all around the house. Same way, blue line, all around the house. You want to have a cover which assures that the air tightness is there. And once you have this envelope, you have an easy play with the NVHR system. Fresh air comes in, exhaust air goes out, and here's the heat recovery. And this heat recovery ensures that your efficiency, your energy efficiency is high, because the heat recovery is between, let's say, if it's a low working engine, 90%, if it's a high performance engine, 95, 96, 97% of your energy stays in the house. Why heat recovery? So you have constant airflow, constant fresh air, constant filtered air with no costs. And then you want to have the house designed so you have the sun, the power of the sun in the house, but you don't want to have too much of that. So the balance is very tricky, very important. You need to have the sun in the wintertime. You don't want to have the sun in the summertime, so you don't get an overheated house. So what you're dealing with is two things. First thing is the quality of the windows, means basically the glass and the frame. Second thing is you want to have shading. You want to have possibility to balance, to play with this external energy source, sun. And you want to end up the heating energy demand lower than 15 kilowatts per square meter, an air tightness with lower 0.6 per hour, and the primary energy demand, which is quite high, over 120 kilowatts per square meter a year. You can do better, but this was a long time ago when Passive House was designed, and the way the primary energy is calculated in the PHPP is not the same way than we'll find primary energy calculated in other standards. For example, our legal standard in Germany asks you to have a primary energy demand of only 45 kilowatts, but they calculate it completely different. So this is the numbers you want to have as maximum when your house is calculated with the PHPP. This is important to know. So it comes down to practical 10 points, the 10-point system, how passive house works. First, mentioned it already, thermal insulation all around the house. Second, very tricky sometimes, no cold bridges, no heat bridges. So every design, every detail has to be designed so you have no cold bridges. Tricky. You need to be an expert in this design to make no mistakes. And then airtightness all around, triple glazing is normal standard for the glazing, triple glazing, air ventilation with heat recovery, number 6. And you have to calculate also the internal gains, means the people inside, the furniture, the electrical demands inside, and so on. You have to calculate that. And number 8, external gains. As I said, the sun is giving you a lot of power, and you have to deal with that. External shading to avoid overheating. And 10, low heating and cooling load. Means not more than 10 watts per square meter, 15 kilowatts per square meter a year. So to give you practical, we architects love pictures. Yeah, I do. So 10 pictures to 10 headlines. Thermal bridge, no, thermal insulation. This is the house I renovated. I'm sitting in there right now, and you see the cover of the insulation. It runs all around the house, the roof, the walls, everywhere. It's insulation, and it's a lot of insulation. And all the details have to be designed so you have no cold bridges. So the connections to the doors, to the windows, to the roof, to the cellar, all these little details have to be designed very carefully, and of course built very carefully. Once you're finished, you want to have an airtightness test, a blower door test, and you will find probably a lot of leakages. So you have to think ahead, how can we get this airtightness and all the little details like pipes they're running through my airtightness layer, like connections to the floor of the windows and the doors and everything, and ensure the airtightness by a blower door test. You want triple glazing, and if you are dealing with triple glazing, you, in practical use, you have to think about the weight, because glass is quite heavy, and if you have a single layer, it's one sheet of glass. If you have a double layer, double the weight. If you have 3 layers of glass, triple the weight. And if you have the south side of your house with and you expect to have lots of windows, big windows, because you want to have a lot of sun inside, then think about it, how to get these windows in there, because they are very heavy. This is an example, the picture shows an example from my house, and this window is not that big. It's 3 meters by 2 meters 50, but it weighs that much that we have to have a crane to move it. You can't move it by hand anymore. So triple glazing has a lot of circumstances you have to think about. And maybe it's smarter if you have a lot of glass to cut it into smaller pieces just to get it in place more easily. Air ventilation system, same trouble that the system itself is very easy and very smart, but you have to run the pipes all around your house. And if you're talking about renovation, for example, then you have to find the proper way to run these pipes. It's the same in a new build. You have to really think about, where do I run my piping? Do I run it in the ceiling? Do I run it on top of my floor, under the street? Where do I run it? Along the facades? There's lots of possibilities. But because of the size of the pipes, they are between, let's say, the small ones 100 millimeters and the more bigger ones 250 to 300 millimeters in a single family house. So they need a lot of space, and you have to think about it. Inside the heat recovery system, it's absolutely easy. This one is an old one, but it's just the functionality is the same everywhere. It's incoming air running through the filter and going out, and all you have to change is these filters, and they are out of paper folded up paper. Very easy, very cheap, no problem at all. Internal gains. Here, as example, computers, people, whatever, you have to calculate it. And this is important, especially for the need of the what we get for the 120 kilowatts per square meter a year. I don't know, but I've showed you already the primary energy. Yes, the primary energy. So that's why you have to calculate it. External gains, easy, but also very tricky sometimes because the sun's there everywhere, but they're not shining all the time, and there might be a bigger house, there might be a tree, there might be your orientation basically, so you have to calculate where is my sun, how much power can I get from the sun, and from there looking east, especially south and also west, on my side of the earth. On the other side of the earth, it's just the other way around. You have to calculate how much can I gain from the sun. And if it's too much, you have to have the shading. This can be a very nice idea for the architect to build a nice cover for the house. You have to deal with this shading to make it colorful, to make it interesting, whatever. But you have to think about the shading, very important. Don't just think about the external gains, also think about the overheating load you get if you can't cut it off. And low heating and cooling, also for heating or cooling, not more than 15 kilowatts per square meter a year is the magical number. And the world climate zones are very different. You find them from red to yellow. You find hot zones, cold zones, you find humid zones, you find dry zones, you find a mixture of all of that. And of course, we in Germany, it's somewhere here, we have a moderate climate with not too much humidity, so it's quite easy for us. But meanwhile, you find all over the planet, almost all over the planet, passive house quality built, and we can tell that all the houses are working. It doesn't matter if it's a dry or humid zone. It doesn't matter if it's a warm, moderate, or more cold zone. Of course, it has an influence on the calculation and the results. In more cold zones, you have more insulation than in moderate and warm zones. But it works, it does work in all the zones, and the buildings you are designing is about here. So it's not moderate anymore, it's more between moderate and cold. Humidity is quite normal. You get the numbers you need to do your calculation, but you will see a Passivhaus Standard will be easy to reach there also. And just to give you an idea, if you have moderate or cold climate, you need more insulation, more thermal insulation. You have to be aware about the air tightness, of course. Normally triple placed windows, solar gains is more important, internal gains is important, and the ventilation system, but you don't need a heating system. It's enough to have a rest heating, a small rest heating, basically run through the heat recovery. Compared to hot climate, you still need the thermal insulation, but you see the yellow line is compared to this yellow line from the cold and moderate areas is smaller, means less thermal insulation is needed. Also, air tightness is needed, but you can see here this overhang, for example. It means that, especially in hot climate, you have to take more care about the overheating, and this is maybe done by an overhang, by a design you have to cut off the heat from the hot climate from the outside. And what's also good here in 0.5 natural ventilation. You don't need it in moderate and cold areas, but in hot climate areas, you should have, in addition to your ventilation system, a possibility to have natural ventilation, means openings which gives free room of big size. It can also be the ventilation system with a high volume, but you have to think about it. One example, one of the first big buildings in Passivhaus Standard is built in near my town here. The town is called Frankfurt in Germany, and it's out of 4 houses. One is number A here, the second B, and one around the angle here is C, and there's a 4th one, a single house here. And it's 149 dwellings with 156 parking lots and 4 to 8 commercial units. This is the parking lots outside the Passivhaus Standard. Only the house, the top, is in Passivhaus quality. The 4 houses are placed on this ground floor on this parking lot, like the gray lines here show. And just to give you an idea how these houses look like, this is the house called A. You can see this is facing basically northwest. A normal house, you can't tell from the outside this is a passive house. It's nothing special about it. Normal house, but maybe if you focus to the windows, then you see that all these windows are quite big. As is because we are looking for the solar gains. And for example, to face the house B is in the other direction, but also almost the same design on the outside, other colors and so on. But from the openings and the closed partitions of the wall, it's almost similar. And then we are looking at house C. The house C is around the corner. And I would say you cannot tell this is a passive house, yes or not. It's not a special design and so on, but it's carefully done compared to the external gains, and you see that from the inside. We have these balconies, and the balconies are there to provide the overheating, because you see we have huge openings to the south here, but it's not covered by the sun. You see it's covered by the shadow, so this is not providing any overheating in summertime. Very important. On the north side, for example, we have hardly any windows in the wall. And this facade, for example, this is a thermal image, not thermal bridge, a thermal image of the facade in the winter time, and you see only very, very small yellow areas, means this is all coal, which is perfect, and the yellow is not as perfect as it should be here and there a little bit. But this can be because the window was opened a few minutes before or so. But compared to the neighbor's wall, this wall is same time, same area, just round 180 degrees, and you see this house is losing a lot of energy. It's all yellow and even red and warm white areas, which means 11 degrees. And go back to the picture. Even our weak points here are down by let's say 7-8 degrees only. So we have a complete different energy losses than the neighbors. And here's a section. So you see the parking lot, and outside of the parking lot or on top of the parking lot's the house, passive house with the thermal insulation, and this is the stairways, and the stairways cut down in the parking garage. That's why in this area we run the insulation also down to the floor slab and down the walls of the cellar. And the red line is the air tightness. also, as I told you already, just around the house, one time around the house. And what we did here, we have a central heating system with heat recovery for all the dwellings. So we go with one heating system or with one heat recovery system to 10 dwellings in each house. We have the windows, almost all of the windows running down to the floor to make a brighter atmosphere, a lighter atmosphere, a more modern atmosphere of the dwellings, but also because of the calculation of the gains, of the solar gains from the outside. Yeah, as you saw it on the other facades, and you can see it in the detail here as well. We have only a very thin, I don't know, the English expression for Absturzsicherung means that you don't fall down there if you open the window. So we didn't close that with another glass, for example, because otherwise we would cut down the thermal gains. With this construction, we don't cut it down. So we have all this window collecting energy. So, oops. This is just this central heating system to give you an idea. It's very small. This is a picture from the central heating system. So you see, it's not that huge. It doesn't need that much space. And this is all the technique we need to have perfect air condition in the dwellings in every room around the year. And also the heat is delivered by that central heating system. The gray marked areas are suspended ceilings, and that's in the dwellings. This is one dwelling on the left-hand side, a more bigger dwelling on the right-hand side here, and you see the piping. The piping you want to have always only short ways, so you don't have to. Well, I showed you a picture before. They have a certain dimension, and that means that you do, for example, if you do it like we have done it here with suspended ceilings, you don't want to have all the dwelling, the height of the dwelling cut down by suspended ceilings. You want to have only small areas, which we have here, only the central area and the men's room or the ladies' room is with suspended ceilings. The costs, I mean, they're not as representative as they could be, but just to give you an idea, because it's German costs, and German costs are quite high. But we had, let's focus on this number here. We had costs of 1,351 euros per square meter. You might say, wow, this is expensive, but the normal house to legal standard does cost the same. It also costs 1,200, 1,300, 1,400, something around that. This is a few years ago. Meanwhile, the costs have risen a little bit, but just to tell you, we got this house with almost or hardly any extra cost. The Passivhaus Standard in this house has been about 1.5%, maybe 2% of the whole cost only. So the amortization is extremely fast. This is from the inside. It's quite a big building, so we have designed it so prefabrication could be used efficiently. Yeah, it's a courtyard which is in private use of the house owners, and quite interesting. After finishing the house, we gave a user manual to the house manager and the user manual to the house owners and the people are living there, just to tell them what is special about their house, what's with the air ventilation, what's with the air tightness, what's with the windows, and so on, and just to explain them and make them a bit sensitive for for the energy efficiency of their house. And now the house is used for so many years. All of the users are telling us, we love to live there. It's cheap, it's comfortable, it's cozy, it's just wonderful. So this was first presentation, short overview, and now I asked the Saint-Gobain organizer to give me my second presentation, where I can show you in more detail how I've done it to reach Passivhaus Standard in the renovation. Okay, this is the house I renovated down to Passivhaus Standard, and I bought this house 6 years ago. That's how it looked like. This was the north side, and this was the south side. And from what you learned already, you can tell straight away that it wasn't optimized by gaining solar gains, energy from the sun, because north side has a lot of windows, south side has maybe the same. So first get the south side open and close the north side down as more as far as possible. So we made some design. Little extensions have been in our planning, and you see here long, huge windows, big openings here, small extensions of the house in the second floor, also with big openings. So huge windows to the south side, more or less big windows to the west, and hardly any windows or hardly any openings to the north side. So this is how we started. Little extension here on the north side, big extension, or it's not a big extension because it's not a big house, but compared to the size of the house, it's a big extension on the south side. While the house is a brick and a concrete house, the extensions are made out of wood. I come to that later. And when I decided to build a house, I got in contact with Isover, and Isover found the idea to renovate down to Passivhaus Standard so interesting that they said, if you are showing how to do that, we are willing to really support you. And if I remember 6 years ago, I was so surprised, and I really found this a very, very interesting situation. And I still love the idea that we have done it together. Yeah? And you see the date here, it was the 4th of 4 in 2009, so it's almost 7 years now. And we said Baustelle zum Anpassen, that means site to get there and ask your questions, and open site, that's what we did. Everybody could come, everybody could ask, everybody got questions answered. And we got feedback from our neighbors and from all the interested people, and that was it was a super time and very interesting. We started with demolishing south side positioned garage buildings in order to get an extension here, and then we the scaffold around the house to place the insulation. And this is how the existing roof was constructed. And you see we had about 5 centimeters of insulation in the existing roof. And of course, this wasn't enough. So we had the idea to make more of that. Checked the location, especially the roof, of the quality of the wood and so on, if we can keep it, if we have to remove it. And so happily we found the most parts, or even all of the parts in the wood, in a good condition and could keep the roof. And the decision was, to see the insulation, to get more insulation in between the rafters, which is the same size than the rafters have, is 14 centimeters, and on top of the layer of boarding, another 20 centimeters of insulation, and below the airtight layer, the intake film, we have another 2.5 centimeters of insulation. Why do we have this small insulation down here? Because underneath of everything, in order not to cut the air tightness layer too many times, we run our cables in small piping, and the rest is filled with insulation. So altogether, we have about 40 centimeters of insulation, which is 35 more than it was when I bought the house. Here's picture from the side, and I go back to the drawing. This 20 centimeters on top is what you see, what you see here. This is the 20 centimeters, and this is in small pieces, comes with the rain cover and with some glue stripes. It was a new product, brand new, first time used on my house, and was super to work with because it was 50 centimeters, very easy to handle, very fast. Within, you see the neighbor has some snow on his tiles. We have been working in bad conditions. In wintertime, it was snowing, but the house was covered with this insulation within half a day. That was it. So very fast. And once it's on, it's airtight. It's not airtight, sorry, watertight, super material to work with. We checked it after finishing the roof, and it had a lot of shower and rain and everything, snow. And then we checked it, opened one piece, and saw everything is dry, everything works good. So super, we can continue. One little problem, I just go back to the 20 centimeters or go back to the drawing. If you have to bring your under construction for the tiles on top of an insulation which measures 20 centimeters, then you have to find a way to fix these wood pieces here down to the rafter. And this is a long way, and you cannot drill your screw in a right angle. You have to drill it in angles like this way and that way, so they don't move against each other. And that means that you end up with fixing this under construction here in these angles with the rafter, means screws of a length of 45 centimeters. And that's very tricky. If you have a screw of almost half a meter to really drill exactly in the rafter. Took a while to find out how to do it. Craftsmen were not very happy for the first few moments, but it was a new experience for them as well, for me also, and we found a way to do it. But this is the tricky parts you don't get explained normally when you see details like that. But that's what you have to deal with. And what you also have to deal with in renovation, you see it here, you have the old construction, you demolish part of this construction, and still you want to have an air tightness layer. And this is the air tightness layer here, the duplex from Isover. And if you see, if you look carefully, and then you see it's cutting through the rafters here and the wood there and so on. So you can imagine, to really get it airtight, it needs a lot of specified craftsman's work and a lot of thinking and a lot of discussion on site. So you have to be present on site. You have to design together with the craftsman how to really fix your air tightness layer to get it airtight. And the walls were only brick. First floor, no, ground floor 45 centimeters, first floor 30 centimeters, second floor 24 centimeters. And I was hoping that these walls should be airtight by himself, and was designing to get an MVHR system, an EPIC system, means insulation on the outside only and nothing else. I decided to bring stone wool in 2 layers, 14 centimeters plus another 12 centimeters, means together 26 centimeters with some render on top, and was hoping that this wall is airtight. This hope wasn't fulfilled, because once you bring two airtight insulation layers, you see all the white dots. You have to glue and screw. And if you count these dots and you want to count them all around the house, then you find the number quite high. And every dot is a hole in the wall. And every drill in the hole is the possibility that your wall is getting cracks, small cracks. But if you have hundreds and hundreds of these cracks, and you have an old inside, an old layer of render, then you can imagine that your wall here might be not as airtight as you expect it to be after all this work is done outside. So I ended up with walls which had an airtightness problem. So if you go for having an airtightness layer only out of render, it doesn't matter if it's new build or renovation. Think about it. You need to have this render redone. You won't be able to do it with an old render in renovation. And you might be even better if you think about not to do your airtightness layer with the render layer, but to do it with a foil, with a film. Just to give you this. Okay, here you see the render on site already. Of course, it's painted later. Here you see the big openings because we wanted to have all the solar gains south side, really big openings. We have demolished a lot in the house, so even the walls are gone and everything. So it was a lot of steel construction we had to put into this house. Because ground floor now is where I'm sitting right now, is my office. It's our architectural office, and I'm living upstairs. The 2 floors on top of my head here is my dwelling, where I'm living with my family and my dog and so on. So we wanted to have an open space office, and that's why we had to demolish all the walls. Under this house, we have a cellar. This cellar is from 1920, so it's almost 100 years old now. And the whole area here around, it's called Almenhof. Almen are a special kind of tree, which is only growing in areas where this tree gets a lot of water. And it means this almond could only grow because we have a lot of water here. And these old cellars, they have no insulation against water. They are all wet. And you can see here the wetness is climbing up the walls. And also here you can see all wet, and even the steel construction, old steel construction is rotten because of the wetness. So what I had to do is to really decide how far down the cellar can I run my insulation? Because what you can't do is you can't run insulation when you have wet construction. So that was one of the most tricky parts to find out, to find a way to get thermal bridge-free construction and not get into these wet areas. This is one of the reasons, but only one, because why I decided to have the extensions done in wood. Wood can be prefabricated more easily, can be delivered more quickly, can be installed more quickly, is more renewable. So this is the other points, but the dryness of the situation was the most important point to decide to have the extensions in the wood construction. And you see here, all the walls are gone in the ground floor, even the steel construction is there anymore, and the wood construction as an extension is starting to grow. Ceiling is in wood, everything is in wood in the extension. On top of the extension is a terrace. This terrace is based on an insulation layer of 30 to 35 centimeters of XPS. And here you see the extension finished, 10 meters of glass. The rest is wood, perfect. And then we had the last, let's say, problem, which was the existing ceiling to the cellar. the basement was only concrete, 20 centimeter of concrete. So if you're thinking about energy efficiency, concrete's not very good. So we had to decide how to run the insulation, what can we do? And this concrete was very rough surface on the upper side, and it was very tricky on the underside, because we had some steel construction there, we had some bent areas, we had some cables running, some piping running, like it looks in a normal cellar. And then you have to develop an idea how to run your insulation properly. And what we did is we said we go for 10 centimeters of mineral wool in the lower, from the underside, because 10 centimeters we can bend, and so the insulation can follow the construction, and it gets us the fire safety. And on top, we have 5 centimeters of insulating bulk. This is gravel, EPS gravel, to level the rough surface of the concrete slab. And on top of that, we have 2 times 10 centimeters of XPS. And on top of that, we have the floating screed with floor heating. This is how we did it. It was easy because this is very easy to get in there. This is also very quickly done by handcraft. And this is the normal screed we have everywhere with floor heating. Except that the floor heating in a normal house might have, between the little pipes, might have a distance 20 centimeters, and we have only 1 meter and 50 in between, because we need so little heating in the house that we have no need of long piping in the street. So here's the bulks, and here's the other insulation, the XPS, and there's the screed already in the house. This is me discussing something with some craftsmen. The walls outside, the outer walls of the basement, are insulated on the outside with XPS because of the earth and the humidity we expect here, and on the inside also with mineral wool. Triple glazed windows out of wood and of carbon, very high performance constructions. And why triple glazed? Basically, because you can see it here, if you want to gain during the whole year, if you want to gain some energy, you have to go for triple glazing. Doesn't matter which kind of, but with double glazing or with single, you will never have gains, you always have losses. So you have to go for triple glazing. Triple glazing, I told you already, is quite heavy to handle, so you need crane possibility, and you need to, of course, a lot of people to handle it. So even if you know about insulation needs, airtightness, quality, thermal bridging, you will end up in your design, you will end up with some tricky points. As an example here, my piping on the outside under the window, and even there we run some foam out of the box here. You can see it here, just to get even this part of the house insulated, because thermal bridging can be terrible, and sometimes you can't design the last little bit, but you have to at least on site find a solution. Then we had the airtightness by blower door test, tested, and had first of all we had terrible results. We had to redo it a few times, and every time we found new leakages, and we closed these leakages and got the house airtight, and ended up with a very good result. The MVHR system, we have two, one in the office and one in the dwelling. You see, we squeezed it in a little room, which is nowadays the rest of the room is nowadays our toilet. But you have to respect that all this piping and bendings of the pipe and so need some rooms. You have to really plan this. This is not interesting. And then we had some drillings for, because the rest of the heat we need in the house, we have a heat pump, ground source heat pump, and the ground source is this way here. Drillings in front of the house, 3 drillings, 30 meters deep, piping inside, ground source on the heat pump connected. The heat pump is 1.2 kilowatts for the whole house, so extremely small, the size of a refrigerator. That's what we need. And we calculated the house with the PHPP, ended up with 13 kilowatts per square meter. And now, after 6 years, I can tell we are even less than 13. We are somewhere between 10 and 11 kilowatts, so almost nothing to heat and cool the house. The calculation with the PHPP is a pain in the ass because it's a lot of Excel sheets, more than 30 Excel sheets, but you will be ending up with a perfect calculation. It's really, really close to reality, and this is why you should learn how to handle it and do it. This is the house. It's meanwhile it has a lot of awards. Won some architectural awards, a lot of energy efficiency awards. We are very proud, but more than this, more important than this, is that we are very happy and very, let's say, it's so healthy to live in there that we would do it every time again. And since we have renovated this house, we have renovated a lot of other houses to the Passivhaus Standard, and with the same results. The owners would all tell us we would never want to have it different. It's super, and that's what we get told by all the owners of the new build house as well. Passivhaus Standard is perfect, and I really want you to design your houses for the Isover student contest in Passivhaus Standard. And yeah, this is the end of my second presentation. Now I'm here to answer your questions, and thank you very much for listening.
remove the previous version from the computer and you can install the second one. As this, we are more working on a daily basis on it to improve it so that it can even better. This is a navigation, a very simple and